Now the second question, we are given the series expansion of log 1 minus x, and it is minus x square by 2 minus x cube by 3, and it goes on up to infinite when mod x is less than 1. Now first question is, by choosing a particular value of x with mod x less than 1, show that log 2, it is 1 by 2 plus 1 by 2 into 2 square plus 1 by 3 into 2 cube up to infinite. Now in this, what we'll simply do is, we'll let x as 1 by 2. So for this first one, we'll substitute x with 1 by 2. So it will be this ln 1 minus 1 by 2 is 1 by 2. And here we'll get minus 1 by 2 minus 1 by 2 into 1 by 2 square minus 1 by 3 into 1 by 2 cube. I'll continue. Now ln 1 by 2 is minus ln 2. So it will be this minus ln 2, and that will be equal to minus 1 by 2 minus 1 upon 2 into 2 square minus 1 upon 3 into 2 cube, so on and so forth. Now we'll cancel this minus sign. We'll simply get log 2 equals 1 by 2 plus 1 by 2 into 2 square plus 1 by 3 into 2 cube, and which is what we need to prove in this first part. Now the second one is, using part 1 and the fact that 1 upon n into 2 to the power n, it is less than 1 by 3 into 2 to the power n for n greater than or equal to 4, find the integer k such that log 2 lies between k upon 24 and k plus 1 upon 24. Now basically all the terms in this series, they are positive. Now if you look at sum of first 3 terms, this sum will be this 1 by 2 plus 1 by 2 into 2 square plus 1 by 3 into 2 cube. Now this is 24, 12 plus 3 plus 1, 16 by 24. So this log 2 is sum of first 3 terms plus other positive terms. So we can write this log 2 will be greater than 16 by 24 and will be less than this 16 by 24 plus. Now from the fourth term onwards, we are given the condition that this 1 upon n 2 to the power n will be less than 1 by 3 2 to the power n. So if we substitute this, we write this as 1 by 3 and it will be 1 upon 2 to the power 4, 1 upon 2 to the power 5 up to infinite, which is nothing but an infinite GP. So if we simplify this right hand side, it will be the 16 by 24 plus 1 by 3, and this is A upon 1 minus R, and which is 1 by 2. So it is 17 by 24. So from here we can say value of log 2 will lie between 16 by 24 and 17 by 24. So basically value of k is 16. So for the second part, we get k as 16. Now for the third part, it says show that log 3 by 2 is 1 by 2 minus 1 upon 2 into 2 square plus 1 upon 3 into 2 cube. So for this, what we'll do is, in the series of log 1 minus x, we'll simply put x as minus 1 by 2. So log 1 minus x will be log 3 by 2, and then it will be 1 by 2 minus 1 by 2 into 2 square plus 1 by 3 into 2 cube minus 1 by 4 into 2 to the power 4, so on and so forth. This is what we need to prove in this first part, and it says then deduce that log 3 is this value. Now we have already worked out series for ln 2, which is 1 by 2 plus 1 upon 2 into 2 square plus 1 upon 3 into 2 cube plus 1 upon 4 into 2 to the power 4, And if we add them, then we can write log m plus log n as log m into n. So it will be this log 3. If we add them, these terms, they'll cancel. So it will be this 2 times and then 1 by 2 plus 1 by 3 into 2 cube plus 1 by 5 into 2 to the power 5 up to infinite. Or we can simply write this as log 3 equals 1 plus 1 by 3 into 2 square plus 1 by 5 into 2 to the power 4, so on and so forth. This is your second part. Now we need to deduce that this value of log 3, it lies between 13 by 12 and 11 by 10. Now if we look at these first two terms, it is 1 plus and then 1 by 12. So there will be 13 by 12. And all other terms, they are positive terms in the series. So basically, this log 3 will be greater than sum of these first two terms, which is 13 by 12. And it will be less than 13 by 12 and plus. Now, as we have used in this question number 2, that 1 upon n into 2 to the power n, it is less than 1 upon 3 into 2 to the power n. Here we'll take 5 rather than 3. So we can write this as 1 by 5 and then 1 upon 2 to the power 4 plus 1 upon 2 to the power 6 up to infinite. If we simplify this right hand side, it will be 13 by 12 plus 1 by 5 and this is 1 by 16 and 1 by 4. So it will be this 13 by 12 plus 1 by 60. Now this is 65 plus 1, 66, which is 11 by 10. So from here we can write value of log 3 will lie between 13 by 12 and 11 by 10. Now in this fifth part we have to find which is larger, 3 to the power 17 or 4 to the power 13. Now we can write 3 to the power 17 as e to the power ln 3 to the power 17, or this is e to the power 17 ln 3, and the same way we can write 4 to the power 13 as e to the power 13 ln 4 or e to the power 26 ln 2. Now since exponential function, it is an increasing function. So basically we have to find out which of 17 log 3 and 26 log 2 is greater, and corresponding to it, that expression between 3 to the power 17 and 4 to the power 13 will be greater. Now first we look at this 17 log 3. Now we know that this value of log 3, it lies between 13 by 12 and 11 by 10. Now we multiply it with 17, we'll get this as 13 into 17 by 12 is less than 17 log 3 and will be less than 17 into 11 by 10. And if we look at log 2, we know that value of log 2, it lies between 16 by 24 and 17 by 24. Now we multiply everything with 26, we'll get this as 26 into 16 by 24. It'll be less than 26 log 2 and it'll be less than 17 into 26 by 24, which is 17 into 13 by 12. Now if we look at these two values, they're same. So from here we can clearly say 26 log 2 will be less than 17 log 3, or simply 2 to the power 26 is less than 3 to the power 17, or 4 to the power 13 is less than 3 to the power 17. So which is larger? 3 to the power 17 is larger.